Okay, so let's talk about some examples. So we have the integral of 5 times x to the 7th power. So we have 5x, we add 1 to our exponent, and divide by that same number, and add c. 5/8 doesn't really reduce, so we can leave it just like that. Another way that I could write this integral is 5 times the integral of x to the 7th power, and it'll give us the same answer. We have 5 times the integral of sine. If I think back, what gives me sine as its derivative? That is negative cosine. We have 5 sine, so we have negative 5 cosine of x plus c. I have 5 to the x power. That's our a to the x power. So I have, we're dividing by the natural log of 5. We need 5 to the x that we're multiplying by it, so I can go ahead and put 5 to the x in the exponent, and then I'm adding c. If I want to verify that that works or that makes sense, what I can do is take what I got, take the derivative of it, and see if it gives us this as our answer. Okay, and then this last one, one of the things to note is that it says theta, and it's d theta, so theta is the variable that we are working with. So when I look at this, theta to the power of 2 is just a power rule problem. So theta to the power of 2, we add 1 to our exponent and divide by that exponent. And then we are going to do the thing that gave us the derivative is cosine, so the thing that we would have taken the derivative of to get cosine is sine. And we still add our c. Next we have find g of x where g prime of x is equal to 4x squared and g of negative 1 is equal to 3. So in order to find g of x, what we need to do is find the integral of g prime of x dx, and that is going to be equal to g of x. And then we need to use that plus c to kind of help us out here. So we have the integral of 4x squared dx. We're going to use power rule, so we have 4x, add 1, and divide by it, plus c. So we have 4 thirds x cubed, or 4 times x cubed divided by 3. So g of x is going to be equal to that 4 thirds x cubed plus c, and now we need to figure out what c is. So we have g of negative 1 is equal to 3. So I know if I plug in negative 1 for x, 3 is my y value. So what I'm going to do is I'm going to use that information. So instead of g of x, we have 3, 4 thirds times negative 1 to the third power plus c. And then we're going to try to get c by itself. So negative 1 to the third power is negative 1. Negative 1 times 4 thirds is negative 4 thirds. Negative 4 thirds is what's being added to c, so we're going to move it to the other side. We're going to use addition to kind of help us out with that. And then we're also going to change what 3 looks like. So 3 is the same thing as 9 thirds, and now we have common denominator. So we add 4 thirds to both sides. So we're going to have 9 thirds plus 4 thirds is equal to c. 9 thirds plus 4 thirds is 13 thirds. It's not a very nice number, so I'm just going to leave it as 13 thirds. And then now I'm going to do is say g of x equals 4 thirds x cubed plus 13 thirds. And now we know what our constant is, and we don't need to write plus c anymore. For this last one, we have find the position equation x of t when a of t is equal to t squared, v of 0 is 8, and x of 0 is 4. So long term, what we're going to be doing is we are going to take the integral of a of t, and this is going to give us v of t. So we have acceleration. Taking the integral of it is going to give us our velocity. Taking the integral of v of t dt is what's going to give us x of t, that position equation. So we're going to use one, solve for what we need, and then we're going to do it again. So we want the integral of t squared. The integral of t squared, we are going to use power rule. So add 1 to your exponent and divide by it, plus c. Now we need to know what v of t is. So v of t is equal to t cubed over 3 plus c, and we're going to solve for that. So v of 0 is equal to 8, so I have 8 is equal to 0 cubed over 3 plus c. 0 cubed over 3 is 0. 0 plus c is c, so 8 is equal to z, so v of t is equal to t cubed over 3 plus 8. Okay, now that I have this equation, we're going to take the integral of that to get our x of t equation. So the integral of t cubed over 3 plus 8 dt. So we're going to add 1 to our exponent and then divide by it. So I have t to the 4th, and it's already divided by 3. So we're going to divide it by 4 now. Plus 8t, and then we also need a plus c here. We're going to keep using plus c for things. As long as we don't have multiple plus c's in the same equation that we're working on at that moment, it's going to be okay. If we want to separate them so we know that they're different, we can add a subscript of 1, or we can choose a different variable. So let's kind of clean this up. So we have x of t is equal to t to the 4th. Dividing by 3 is like multiplying by 1/3. So we realistically have 1/3 divided by 4. 1/3 divided by 4 is the same thing as saying 1/3 times 1/4, which would be 1/12. So we have t to the 4th divided by 12 plus 8t plus c. So we're going to use x of 0 is equal to 4. So 4 is equal to 0 to the 4th over 12 plus 8 times 0 plus c. All of the zeros go away, so we have 4 is equal to c. X of t is equal to 12 to the 4th over, or t to the 4th divided by 12 plus 8t plus 4. Integration is one of those things that's just going to take some practice. We've been doing derivatives for so long now that doing integration or antiderivatives is going to be a little bit weird at first, but once we get used to it, it becomes a lot easier.